Hi, today I want to get into the schematic and PCB design for the fetch register. It's going to look a lot like a general purpose register, but there are some changes, and I'm not exactly sure how much of the PCB design I'm going to be able to leverage into the fetch register design. So let's get right into it.
Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey.
Okay, you've seen me do this before. The goal here is to copy the register project and then rename it to a different project name. And then once I get in here, I have to clear out the Gerber folder. So I'll permanently delete that. This cache can go away. The backups can go away. This will be recreated. My zip file related to the Gerbers, that can go away out of this one. And then I just need to change each of these file names to match the name of the project. So fetch register. And it's really that easy to get started on a new project based on an old one. So I'll launch the project here. Okay, so first thing we've got to do is get the schematic cleaned up. And this is, again, the register schematic, but there's a lot of things here that don't need to be here for the fetch register. For example, the counters do not need to be here, and these are all the 193s. So there's no counter associated with the fetch register. Address bus 1 is going to be replaced with the instruction register. Address bus 2 will continue to be in play here. ALU-A will not be needed for the fetch register. ALU-B will. The main bus will, but we will not be swapping from the fetch register out onto the main bus. So this will go away. Because we don't have a load, increment, and decrement, we have a load but no increment and decrement. This section with the 138 can go away, and we don't need a decrement, we don't need an increment, but I do need the load line here. This will have to be dressed up a little bit, I think, because I don't believe I need this. I don't believe I need the decrement. I don't believe I need the increment, which means that these two are likely able to be moved over here. Well, I don't need address 2 either, and ALUA. So I will have to get the board out to make sure that I'm putting these into the right spot. I don't have a swap bus assert. I don't have an ALUA. I don't have an address bus 2. I do have an address bus 1, but it's called instruction. Instruction register assert. And I believe I do have the line drivers to display the output. Let's see here. No, the load is really called, well, I guess I can call it load, but it's tied to the clock. Now my header's over here. ALU bus A can go away. Address bus 2 can go away. Okay, I need an input, which is going to be an output off the pins. And that's going to be memory bus 1. So this is the address that's coming off of, or the memory contents coming off of address bus 1. Well, that doesn't work. Let's go collect. Okay, so there's my latch. Now I need to get the breadboard out and start tracing my signals. Okay, I'm focused in on the fetch register, which is from this breadboard here down to this breadboard down here. So all of the contents of these, let's see, I guess I got four here, four breadboards, is the fetch register. And the first thing is there are four outputs, so four sets of line drivers outputting onto separate buses. The instruction register bus if you will, instruction register here is already hooked up, and then I've got the main hooked up here. So I've got ALUB and address 2, and I neglected address 2. So let's go fix that. So what I'm going to do is I'm actually going to open up in KiCad the 16-bit array register schematic, and I'm just going to copy these and paste them right in here. And I think I've got to move these up. Next up is the 5 control lines that I've got, and I've got 4 of them sitting here. I've got main bus assert, ALUB assert, the instruction register assert, and address bus 2 assert. Plus, I also have the raw clock coming in, which I use to latch the register. So let me get back and clean those up. So there is no clear signal. There is a raw clock. There's no swap. There's main. There's, instead of ALU, well, there's no ALUA. And this one's going to be an instruction. So on the left is the raw clock. Next up on the list is the main bus assert. Then there's ALUB, and then the instruction, and then address bus 2. So I can move the 3 of these at once. Let's try that again. Okay, so that should then allow these to all go away. And I should be able to very simply copy and paste here. Now, I need to change that symbol. 1.5 socket. The next thing I want to look at here is the input from memory bus 1 has pull down resistors here. That way, if nothing is actually being asserted from the memory, we end up with a 0 being latched into the latch here. So let's see here. These are the lines that need the pull downs, are these 16. So I'm just going to pull these over here for now. Get rid of this. Let's move those. Get them all in a row. Rotate, rotate. So those are all in good shape there. I'm going to grab this and bring that down here. And now I'm going to come up here and I'm going to grab some resistors. And these happen to be 1Ks and formatted the way I like them. So I'm just going to stick these right here. So there's 5, 10, 15, and one more makes 16. So if I select all of these, I should be able to grab and come down here and then grab again and move those back up. And then I've got everything hooked up the way I need it to. So that should take care of the pull downs. That should take care of these pull downs here. Now, up here, I've got pull downs as well that sit underneath these green wires off to the instruction register. So I really need to duplicate this for those pull downs as well. Do I need pull downs for the other 3 outputs? And I do not believe I do. I believe I'm going to be able to get away with not having pull downs for those because the main bus is going to have pull downs in a separate spot. Address bus 2 should not, if it's not being used, it shouldn't need a pull down. And ALUB, if it's not being used, it shouldn't need a pull down. So I think I'm going to be okay with that. With that said, let's take all of this, copy it again, and paste it. So I have an exact duplicate here. But these are not the signals I need. Let's go find them. Let's double check here. I should be able to pull these. Now these are in the exact reverse order as these memory bus 1. And does it make that a difference? No, it does not. Okay, I've got my signals here. I'm going to change the name of the raw clock, only because that's the only one that's got a space in it, and that's my brand of OCD. This load here should be the raw clock, which I will need to place someplace. I only have 5 LEDs that are being used, so one of these latches can go away. And it's address 2, which I am missing because I removed it like a fool. All right. Address bus 2 assert. And that gets changed to an input. That goes away. That goes away. That goes away. My raw clock comes here. It's going to be an input. That's the same as this AND latch, so that can go away. Sorry, I'm looking to make sure that I get this right. The main bus assert, then the ALUB, then instruction, and then address 2. So these can be moved as a block. And then this goes here. And then these 3 get tied to ground. That's my latch LED line. Then I've got my main LED line. Then I've got my ALUB line. Then I've got my instruction and then my address bus 2. So this does not need to be there. That does not need to be there. That does not need to be there. And that does not need to be there. These are not connected. Oops, got that wrong spot. All right, my control signals now. 19 is tied, 19 is tied low. 1 is tied low. And then I've got power and ground. So that then allows me to remove all of this. Now, I believe I want to change the resistance. Okay, now I'm looking at this and wondering about naming convention, so bear with me while I go look at the code. Okay, I've got fetch assert main, so main bus group 1. The main assert comes from directly off the instruction word. I just have to select which group and instruction suppress. But the point is that this is a suppress, not an assert. So now I'm going to call out that on my breadboard I have these two swapped, and it really doesn't matter which one I hook that line up to, whatever makes sense for routing. The key is I've got to remember that I'm actually have that leeway when I go to route. Instruction register 1 suppress. I said instruction register 1. I just meant instruction register suppress. Main bus assert. And latch doesn't exist. That's raw clock. And I'm calling that raw clock because it comes straight off the clock module, not off the control module. I think I've got these 5 signals worked out. I've got the pull downs here plus the inputs off the main one. I've got my pen pointing, but my main one, memory bus 1, to the latch here. And that's connected up to the raw clock. Raw clock goes off board. All right, so off the register bits 0 through F, those should all be inputs into these line drivers, and they are. And then these are all just line drivers leading back off the register with pull downs there, and I've got those. I believe I've got everything here. So let me save that, and then next step will be the rules check. All right, so before I run the rules check, I want to completely re-annotate this schematic, and then it's just a matter of running the ERC. Okay, I'm shocked that I only have one error. I really am. Label not connected to anything, and that's because I missed it. That should do it. Ha, yeah, I'm a little floored by that. Okay, let's get into the PCB layout. Let's get rid of the zones so I can actually see the traces. And then we'll go ahead and update. And those are all the new resistors I've dropped in, so we'll set those there for now. Now that removes out all of the ICs that aren't used. Unfortunately, I believe the problem here, or part of the problem here, is going to be in, say, for example, this header here, which was supposed to be 10 wide, is now 16 wide and was stacked on top of another header. So yeah, the challenge here becomes my assignments. My new locations follow the assignments as opposed to the what they actually were and connected to. So I am likely going to have to redevelop this board completely. For example, I don't have any more 193s here. This is, and I don't know exactly what it is, this is the 541. Now, I can probably drop it right where the 541 was supposed to have been, whichever one it belongs to. But that may not be the right thing to do because I end up with a board that is about the same size. So I have a feeling I'm going to have to ultimately redevelop this whole thing. And let's start by getting rid of all of the traces and see if I can get everything dropped into the right spots. Yeah, that looks like it crashed. Didn't like that one. All right, let's continue this. I'm trying to get the pins laid out properly, and I have to identify what each one is. So I'm going to put this in hyperdrive mode at this point and do a little bit of voiceover work. The first thing I had to do was try to figure out exactly what pins went where, what headers went where, and it took a little bit of doing to do that. One of the things I realized was my control jumpers were too large, and then I actually had the instructions misnamed. Then I moved into lining up all of the ICs and making sure all of those are set correctly, and I made an effort to center everything. So I've got the IC on one side and the capacitor on the other side, and made sure that they were properly centered this time with each other, with respect to each other. I realized that there's really a lot that I need to go and manage and move around and find the right components for whichever header they're associated with. And it took quite a bit of effort to do that. I would have been better off dragging everything off the board and dropping them all on and just basically developing the board from the ground up. Here I'm trying to make sure that the flow of the signals goes from inputs to outputs, the inputs being on the left-hand side of the board and the outputs being along the top and bottom. Now I'm finally realizing that the ICs are not in the sequence that I would prefer them to be in, and therefore I am going and finding each one in turn and dragging it into the correct position. When you see me overlap an IC and then kind of drag it out to the correct position, what you're seeing is me trying to get things aligned, and I prefer to have everything sequenced as best I can, or at least spaced equidistant. You should see me try to hang pictures in my house. These LEDs and resistors took me quite a bit of effort to sort out and get into the right sequence. I finally had to give up trying to deal with them in groups and start dealing with them one at a time, actually separating the LEDs from the resistors. And the reason I had to do that is because everything, all of the component IDs got renumbered, and when it went to the PCB, they were all still in the same position relative to their component ID. So it took me quite a bit to get through all of this and get everything sorted the way I want. And I still don't have all of the labels and everything that I want handled properly yet. This is me trying to make sure that all of the LEDs and resistors are spaced equally from each other. Cleaning up some of the silk screen to make sure that it doesn't overlap. I had to add a capacitor here because I had miscounted, and I wanted to make sure that the capacitor numbering was correct. And here I am messing up all my hard work. I'm going to have to go back and do something about all of that anyway. Okay, I think I've got everything placed where I would like it to be, and now it's just a matter of wire up. I know this video is, well, I really don't have any idea how long the video is going to be until I get all of this edited up, but I suspect I've run over my my desired limit here. So I'm going to cut this off here, and I will do a wire up as a separate video. Thank you. We'll see you soon.